Hi everyone, and welcome to part 2 of Threads, in which I'll show you how to do threads in the Karel J. robot world. Before I do that, there's one thing I overlooked in my last presentation, and that is that you can give names to threads. So if we look at the frog object here, initially I had the frog have its own name string, but what we can do instead is create a constructor for frog and pass its name along to the thread, and then the thread will bear the name, and all we have to do is call getName to retrieve that name, and we won't need a private variable for the frog. So that's all I had to say there. That's out of the way, and let's move on to robots. It turns out that all the robots in Karel robot inherit from thread, so they can be run as threads. Here I'm creating something called a thread bot that extends robot, and you should be familiar with these arguments. We just collect the constructor arguments and pass them on to the parent class using the keyword super, and as a thread we implement a public void run, and in this case I'm just having the robot make a square. So this is basically a thread making robot. I'm sorry, a square making robot. Okay, so and now to run this robot, there are a few tricks that I had to dig to figure out. This is the standard setup for the world. We reset it and set it to be visible. And we create a couple of these thread bots, one at the intersection of 2 and 2, and the other in the intersection of 4 and 4. And when these robots run, they will describe squares. And the way to add a thread to the world is by the setUpThread method. So instead of doing what we saw in the previous tutorial, in the robot world we just create the thread and pass it to setUpThread. These won't run until you show the speed control, and that's the way to start threads in the Karel robot world. So if any of you were communicating with me what I was having trouble with, this was it. And I discovered that you start threads by invoking the speed control and then, as you'll see, pushing the button. So this should be pretty straightforward. Let's compile and run this. And the program creates the robots. Whoops. And then it opens up this control panel, and we're able to set the speed at which the robots will go. And let's crank it up just a little bit. And then when we're ready to see what happens, we just click resume, and the threads are started. And as you can see, the robots describe their squares at the same time because they're operating separate threads. Okay, let's get on to something a little more interesting. Here I'm recalling the strategy technique that we addressed while we were doing the Karel robot sections. And to review, a strategy is an interface. This strategy is specifically for robots, obviously. A strategy is required to implement the method doIt and take a robot as an argument and then do something with it. The interface declaration just declares this method and anything that subclasses it has to implement it. All right, and we create two subclasses of strategy. A strategy that does nothing. You can see we define the method here, and there is nothing in the body. It just does nothing. And a strategy called make square. Now this is a little more, in one of the other examples, we had a strategy called make square. This is a redesigned version that's a little more sophisticated. It takes, as its constructor, arguments of width and height that specify the dimensions for the square. And then the do it method has the robot create that square based on the dimensions. I'm not going to go through the code. If you have questions about it, you can contact me, but I assure you it works. And now we make a new kind of thread robot that accepts a strategy. Let's take a look at this. So we have the constructor here. Strat thread bot extends robot, so we pass the usual arguments on to the superclass constructor. And by default, it has a null strategy, so it does nothing. It has the required run method for the thread, which just runs the strategy with the current robot, designated by the keyword this. And finally, we have a method called setStrategy, which allows us to give the robot a strategy. We could make an additional constructor that accepts a strategy right off, but I'm not going to bother with that. Okay, we've gone through everything we need except the main method, or the main class here. Let's open that up and see what we do here. Okay, standard world setup, reset, set visible. We create a first robot at the intersection of 2 and 2 facing east, and we give it infinity beepers, so it will never run out of beepers to put down. And now we give it a strategy, which is to make a square of width 5 and height 4. And then we pass it to the world, we set up the thread by passing it to this world method. Now we make a second bot that is born at the corner of 3 and 3 and makes a smaller square, 2 by 2. And so when we run this, they should describe the squares simultaneously. Okay, let's watch it work. Here's the control panel. Let's crank up the speed a little bit and let's go. So you can see they're working at the same time. And the one that has the smaller job will, of course, finish first. And then the other bot continues on to complete its job. Okay. Hope that gets you going, and your assignment is to choose one of your previous robot projects and implement it with more than one robot using threads. So we should see multiple, at least 2 robots working on whatever you're trying to do at the same time. So I'll let you choose which project to review. So that's it, and contact me if you have questions.